Well, today I will be presenting a short contribution, 30 minutes, on the discovery of the Milky Way. And this is a work that I've been doing with Christina Freitag. She's working with me at the Faculty of Physics of the LMU in Munich University. And from the educational point of view, I would like to explain a bit why should we address the topic of history of astronomy. So did you change the slide now?
Yes, it did. Yes.
Okay.
It did.
So we should learn about the development of the scientific method. Research is not static, it's changes driven by inquiry. In astronomy, there are many historical figures who are a true inspiration to many students. And I love to, for instance, and I know many people like to read biographies of the scientists, of the greatest scientists. And scientific research is not only intellectual. This is what we learn about out of these biographies. It requires emotional commitment to overcome a huge amount of frustrations. And fourth, in storytelling, you can connect and gather a lot of information in your mind that you otherwise would just lose. So these are for us the four reasons of why teaching history of astronomy is so important. And I worked many years in extragalactic astronomy. And when I was working at the House of Astronomy, I started to write a book with my husband and a colleague, Aunt Latusek. My husband, Harald Lesch, the discovery of the Milky Way. And this is, well, my first workshop on these contents. So the first thing that you should present to your students or pupils and explain them that since thousands of years in other cultures, people are looking to the sky, but not only to the sun, the moon, the planets, the stars, the constellations, but also the Milky Way. And the Milky Way plays a very important role in many cultures, like in Egypt, in China, by the Mayas, in North America. And you can see here very beautifully the Milky Way represented in Egypt in a hieroglyph. I saw it, the original one, and I was really fascinated to see how with this boat they travel along the Milky Way. But in our story, our own story is comes from the Greek mythology, and this is the story about Mercury bringing Heracles or Hercules to Hera to drink her milk in order to become immortal. And she had a pain because he was really very strong. And then a lot of milk spread around the sky. This is why we call the Milky Way the Milky Way. So, another thing that is very important is that when children and pupils, young people, look at the sky, and if they happen to see the Milky Way, then they don't know where they are, what they are looking at. So it's very important to build with them a nice model of the Milky Way, like the one shown here. And it's very important to put some cotton up and down and feel it such that when you take the model and show it edgewise, then you can explain what you're looking at the sky. So this is very important. And also, it's very important if you happen to live in a city to know where the Milky Way is crossing the sky, because on the cities, the pollution does not allow you to observe with naked eyes in a very nice way the Milky Way. So the first link that I shared already is an exercise where you see the Milky Way, and you should recognize some constellations on it, and then you can pick and drag these several constellations to fit them. They not all fit into the Milky Way, but you can see that if you pick and drag Cassiopeia, you can place it here. And this makes you easier to recognize the Milky Way when you have a light pollution. So to imagine the Milky Way is up there following along these constellations, this is a very first step. The other step is that after 3,000 years of observing the Milky Way with naked eyes, Galileo Galilei was the first one to build a telescope and not only observe the moon craters, discover 4 moons of Jupiter, and also have a look to the sunspots and to the Venus phases, but he also observed some prominent constellations like Orion, and particularly he focused on regions where he saw a sort of nebula, and he discovered on them a lot of stars. So plenty of stars that you cannot see with naked eyes. And the same he did with the Pleiades. And then he discovered here in these gas regions and this nebula also a lot of stars. So he concluded that the Milky Way is nothing else but a mass of innumerable stars planted together in clusters. So he left us with this discovery, and now we know, or by that time people knew, this is a system full of stars, and the question was, where are we in this universe of stars? Where are we located? What is that? Do we belong to this star system or not? And this task is really tough because you can imagine yourself in a forest and you stand beside a tree. You cannot move. And then you should find your position on a forest and also try to figure out the shape of the forest and the size of the forest. So this was a great challenge for these astronomers several centuries ago. And of course, the first step was to start to count stars. And this is exactly what a musician called Friedrich Wilhelm Herschel did. He moved from Germany, from Hanover to Bath in England. And now I will tell some anecdotes of their lives, because he really went through a transformation of personality. He was really committed to music, and he was well known, but after a concert season, he was so exhausted that he took with him some tea, some books, and closed himself 4 days in his room. And when he came out, he was transformed into an astronomer. He wanted to build a telescope, and his sister Carolina had to feed him because he was polishing mirrors 18 hours without stopping. And he built, in an amateur way, the largest telescopes of that time, even larger than those of Greenwich. And you see him, a picture of him climbing up in the telescope. And usually Carolina was taking some notes, seated somewhere, and took the coordinates and the descriptions of Wilhelm Herschel. So this is an example. And their home was a music school, and it transformed within 1 week into the largest telescope factory of Europe. He discovered with this telescope, a 22-foot telescope, the planet Uranus, and 20 years later, he discovered the infrared radiation. So he was really very in love with physics and astronomy. And what he decided to do was place in Bath. He divided the sky above him into 3,400 cones or cylinders, and he started to count the stars without the cones. And he counted around 50,000 stars. And he thought that in the cone with less stars, the Milky Way was very thin, and in the cone with much more stars, then the Milky Way will be thicker. So he was mapping, tracing the Milky Way by counting stars. And this is the first map known map of the Milky Way with these 50,000 stars. So this was an amazing work, but at the end he gave up because he knew he needed the distances to the stars, and he was not able to measure them. So while Herschel was counting stars, a young boy was crying at school, desperate and frustrated, because even though he was very good in maths, he was very bad in Latin, and he couldn't finish his school. So this was Friedrich Wilhelm Bessel, and then he started to go to a business school and to learn how to get involved in trade of goods. And being in this school, he started to dream about taking a ship and going to other countries. And then he asked himself how to find the position of this ship in the ocean. And the answer he got from the stars. So he started to build his instruments. And then he was so excited about astronomy that when he finished, he went directly to an observatory to work. And without having a school diploma and a university diploma, he became a professor of astronomy in Königsberg. So people knew that the constellations that we see at the sky are not all made of stars being in the same plane. That is a projection. But nobody had measured, and they had tried very hard, the distance to a first star. So he was thinking about how to do it, and then he asked Joseph von Fraunhofer, living here in Munich, where I'm located, to send him an heliometer, an instrument built to measure the diameter of the sun in a very precise way, in a very accurate way. So with this instrument, he started to select some stars, and he found the star in Swan 61, Cygni 61, who had a very large proper motion. That means it was moving rather fast compared to the fixed stars of the background. And he tried then to apply the method of the parallax, which had been proposed before, but nobody had been able to measure this angle. So you observe a star from a certain position of the Earth towards respect to the background stars, and then you wait 6 months and measure it again, the relative position of the stars, and you see that the stars makes a jump from one position to another. And you have to measure this angle, and with knowing the size of the astronomical unit, the distance between the sun and the Earth, and with the tangent of this angle, you can measure the distance to the stars. So this is the method that he applied, and he found a parallax, an angle of 0.3 arc seconds, which corresponds to 11.4 light years. And this is amazing. It's very far away. Attached to this parallax method, we define in astronomy that when the parallax is 1 arcseconds, the distance corresponds to 1 parsec, which is 3.26 light years. So this is a very, very important step on measuring the size of the Milky Way. And it also is the method that really showed that the Earth revolves around the Sun. This was already proposed by astronomers after Copernicus, but they were not able to measure this parallax. So in this way, Bessel came to be well known worldwide. And we have made an exercise that so that if you push the link, activate the link, you can measure the parallax of the star Vega by applying this method. So you can do it online, and you can also build a model if you're in a classroom. Now we go farther away. So we need more stars, more parallaxes, more distances to have an idea of the structure of the Milky Way. And this work was done by Jacobus Kapteyn. And he studied physics in Utrecht, and he got a professor position in Groningen. But when he went there, the government did not give him financial support to build another observatory, because there was an observatory in Utrecht, in Leiden. So this was the first astronomer without a telescope. And he was really desperate. He tried 10 years to build an observatory. And finally, he was very lucky to hear about David Gill, who was an English astronomer working in South Africa in the South African Observatory. And he had a lot of photographic plates that he could not measure. He was trying to produce a largest catalog of stars with positions and brightness. And Jacobus Kapteyn was very happy to join efforts. And this is the first collaboration, international collaboration, that we know in astronomy related to galactic astronomy. So Jacobus Kapteyn received huge amounts of plates. He thought he would finish to measure the brightness and positions in 3 years, and it took him 13 years to finish. Among these plates, he was able to measure more parallaxes and develop a method called the statistical parallax. That is, you can imagine that a group of stars that are nearby have the same parallax of a star whose parallax you are really actually measuring. So he worked in the statistics. And he got this model of the Milky Way, placing the sun at the center and by tracing some parallaxes and stars, he went further to 20 light years. And he realized that there was a limit of this method, and he could not measure further distances. So another method for measuring greater distances to the stars was needed. And from Groningen, we are now making a jump to hear about the life of a young woman who would have loved to study astronomy, but at that time in Harvard, in the Harvard College, and the Harvard University, women were not allowed to study physics and astronomy, but they joined with the work Pickering. Edward Pickering was the director of the Harvard College, and he had a group of women making a work that was really hard. They were called the Harvard computers, because they were measuring huge amounts of photographic plates, looking to the brightness and positions of the stars. And Henrietta joined this group and made a really, really wonderful work. She was quite deaf, so she couldn't hear much. And Pickering gave her the task to measure variable stars on a plate showing here the small Magellanic Cloud. And these plates were taken in Arequipa in the Harvard Observatory in Peru. So she was also receiving a huge amount of plates, working days, months, and years. And in this small Magellanic Cloud, she happened to discover many variable stars. We call them Cepheid stars. And she studied her periodicity. And in one publication with Pickering, she really made a footnote stating that it is noteworthy to note that the brighter variables have the longer periods. And this was the method that the astronomy was lacking to measure larger distances. Because if the luminosity correlates with the periods, you can measure the periods of a star of variability, and then you can obtain automatically the intrinsic luminosity. If you know you have to calibrate with another method like the parallax, but once calibrated, you can apply this to measure distances. And this was the case because you could measure the periodicity of the variability of stars and nebula. At that time, they were not called galaxies, they were called nebula. And you knew the periodicity, and then via the periodicity luminosity relation, you could obtain the luminosity, and then you could compare how dimmed was the brightness of these stars due to the distance to us, and in this way estimate the distance of this nebula to us. So this was a revolution in astronomy. And as part of the exercises, you can calculate in 2 steps using the periodicity luminosity relation, the distance to 3 variable stars. Now we skip to another transformation of personality that took place in Virginia. And this was the case of Herbert Curtis. He was a teacher for language, for ancient languages. He was really devoted since his childhood to ancient Greek and Latin, so he became a teacher. And he moved from one school to another school, and it happened that he was cleaning and ordering a library of the new school, and he found there a telescope. And you can imagine what happens to a curious person who finds a telescope. He started to look through the telescope. He took it at home, and 1 year later, he had learned so much about astronomy that he applied for a position to teach physics and astronomy, and he got it at the Virginia University. So he was really amazed about this change of interest, and he called itself the switch. And while Herbert Curtis was switching, there was young boy, Harlow Chapley, playing around cornfields in Missouri, and he was very poor, but he had a huge imagination. So he started to write some criminal stories for the newspaper, and he received a fellowship. And he finished in 1.5 years, 4 years of school, and then with a fellowship, he went to the University of Missouri to study journalism. But there was no career for journalists yet, So he took the carrier lists of the university and started from A to Z, and then he read archaeology. He had no idea about what was archaeology, so he found astronomy, and then he was appointed as a student for astronomy. And he developed a passion for astronomy that was amazing. And both of them met and took a train to Washington to have held some talks and participate in a great debate on the nature of the nebula seen in some of the photographic plates. So they were having two different positions. Herbert Curtis was convinced that these nebula were galaxies, were stellar systems like the Milky Way that are very far. But he couldn't have a method to prove this. And Harley Shapley said, well, no, I'm using the method of Henrietta Leavitt to measure the distances to the global clusters that we see. And indeed, he found that the center of the Milky Way was surrounded by several global clusters, and that the sun was somehow displaced from the center. And he estimated, by using the luminosity periodicity relation of the variable stars of these globular clusters, a huge size for the Milky Way, 100 kiloparsecs, 300,000 light years. So he was stating and convinced that these objects, nebula, were inside the only Milky Way, the only galaxy existing at the universe, our own galaxy. So this debate was open. Nobody won this debate. Nobody was able to convince the assistants of the debate. And another astronomer had to solve this problem. And then this is when Edwin Hubble comes into the history of astronomy. He has also a very hard life because he was very good in math and physics. And in sport, you see him as a member of a basketball team. And he got a fellowship and he went to England, to Oxford. But instead of studying physics, he studied to become a lawyer because his father put pressure on him so that he became a lawyer. So he got back to the US, and a few months later, 1 year later, his father died. So, and then he joined First World War, defending England, and went back. And then he decided to become an astronomer. And he started to do his PhD beyond the 30s, which was quite late by that time. And it was Herbert Curtis, the guy taking part of the debate, the astronomer taking part of the debate in Washington, who asked him to look for variable stars on the Andromeda Nebula and to look also for nova. So, and he looked at a star that was thought to be a nova, but comparing photographic plates with old ones, he realized that this star was a variable star. So he applied Henrietta Leavitt method, and he got an amazing distance to the Andromeda Nebula of 8,000 light years, 800,000 light years, or even 1 million light years. And this is just the great discovery to solve the mystery of the nebula. There are separated systems. This was the moment of the discovery of the Milky Way, of an own stellar system among a huge amount of other galaxies. So to tell the story, I think that it's really, really important, because you don't use a method by learning it at the university. The method and the creativity goes in the minds of the astronomers. So you have to change methods, you have to try other ways to solve the open questions of astronomy. So I conclude by saying that we are children of the Milky Way, and this is the title of a book of Harold Shapley, and by mentioning that it's the gravity field of these galaxies that keep the chemical elements produced during supernova explosions. And so we are really children of these systems. In smaller systems like dwarf galaxies, the chemical elements are spread away into the cosmos when the supernova explodes. And I'm really fond of teaching this to young pupils. You can see a picture of them of a summer school that we offered here. And so the workshop is designed to make a model of the Milky Way, to find the Milky Way at the sky by picking and dragging some constellations with these interactive links that I sent you, and to measure the parallaxes of some stars, and then to answer some questions. Why was Shapley's Milky Way model so large? So I would like to stop here and see if somebody wants to answer question number 6. Thank you very much.